Hello Math 2 students, and welcome to your absolute value video. All right, so we've talked about transformations a little bit. Now we're going to talk about how to actually solve absolute value functions, or I guess I should say equations. So to review, absolute value is the distance from zero. The absolute value, just like distance, is always positive. So whenever you evaluate something with absolute value brackets around it, you're going to get a positive value out. Okay. Now that doesn't mean that, like, for example, when you solve for x, that you're always going to get a positive value. What that means is that when you evaluate what's on the inside, your output always has to be positive. So let's go ahead and just take a look at an example of how we solve absolute value functions. So let's go ahead and look at this first one here. We've got, you would read this, the absolute value of 5 minus 2x minus 11 equals 0. So it says isolate the absolute value. So the first thing you want to do is you actually want to get the things with the absolute value brackets by itself. All right, you want to get it on one side of the equation. So if you look, this negative 11 is on the side with the absolute value. So we want to move that over. So we're going to add 11 to both sides. And we get absolute value of 5 minus 2x equals 11. So now we've got our absolute value by itself. So what we want to do now is we want to split it up into 2. The reason for that is because when you evaluate this, all right, whether we have the absolute value of 11 or we have the absolute value of a negative 11, these are both equal to 11. Okay, so you have to account for the fact that you might have a positive 11 on the inside, and then you have to account for the fact that you might have a negative 11 on the inside. So to do that, we're going to split this equation up into 2, and we're going to say, okay, let's say we have a positive 11 on the inside. You do that, and then you solve for x, right? You would bring the 5 over, do minus 5, and then divide by negative 2, and you end up with x equals negative 3. That's all good and dandy. Now we have to account for the idea that we might have a negative 11 in there. So we say, okay, well, what if we set the inside equal to negative 11? You do the same thing, subtract 5, divide by negative 2, and you end up with 8. All right? So for a lot of these, you're going to end up with 2 different answers. All right? So this part of the video wasn't in your notes, but this next part is going to be in your notes. So go ahead. For those of you who are in person, you should have this printed out. If you don't have access to a printer, no worries. Just do it on notebook paper. But make sure you take notes because you're going to have to hand them in. So let's go ahead. Let's just do problem 1 first. All right. So if you notice, the absolute value is already isolated. So we don't have to do much work there. Now, all we have to do is take what's on the inside and set it equal to positive 9. And then take what's on the inside and set it equal to negative 9. So if you notice up here, the absolute value wasn't by itself to begin with. Here it is. All right, we have to go through and say, okay, well, it's by itself. So now we kind of had less steps, I guess, because it's already by itself. So we divide by 3. We get x equals 3. And we get x equals negative 3. So we got 2 possible answers there as well. All right. So then let's go ahead. We'll do problem 6. All right. So again, notice how our absolute value is all by itself. You don't have to do a ton of work there. We're going to break it up into 2. This is really thick. There we go. We'll say negative 4 plus 5x equals positive 16. And then negative 4 plus 5x equals negative 16. Then we just need to solve these 2 equations. We're going to add 4 to both sides. Divide by 5. And I get x equals 4. And then for my other one, I'm going to add 4. I get negative 12, so I divide by 5. And I get x equals negative 12 fifths. All right, so we end up with 2 answers there as well. All right, so now let's try one where we have to isolate the absolute value. So let's try number 12. All right, So keep in mind, we need to get this absolute value by itself. So it's kind of, I want you to think of it the same way as like, okay, like if I had 3x, this is different, but let's say I had 3x plus 8 equals 80. What would be the first thing you would get rid of here? It would be the 8, right? So we're going to do the same thing here. We're going to get rid of the 8 first. So we're going to do minus 8, minus 8. And we get this. And then we just have to divide by 3. And we get 24. All right. So now we can go ahead and split this up. And we say negative 8x equals 24. And negative 8x equals negative 24. Why did I split it up at this point? Because my absolute value is all by itself. I'm not adding anything to it, subtracting anything, multiplying. It's all isolated. So we can go ahead and finish. I'm going to run out of space here. So for this one, we end up with x equals negative 3. And for this one, we end up with x equals positive 3. All right? So that is how you would do something like that. All right? Let's see. Let's do a couple more here. All right, let's try number 15. I feel like this is going to trip people up. So, again, we're trying to isolate this absolute value. So, to get this absolute value by itself, we need to get rid of the 8. So since it's being divided by 8, we're going to multiply by 8. So multiply by 8, these guys cancel. We multiply by 8, we get 24. And now our absolute value is isolated. We can split it up into 2. We go ahead and start solving. So we're going to bring the 4 over. Divide by 7. Minus 4. I get a negative 28. Divide by 7. And I get p equals negative 4. All right. So again, your goal really is to get that absolute value all by itself. And then all you need to do is set it equal to the positive and negative value. All right.